Hi, students and friends. This is your host and teacher Sayyid Ayazuddin Haider, and you're watching Learn and Teach by Sir Ayaz. So, this is a video session for O level past papers, and this time I've selected IGCSE Chemistry 0620. For this video, I have selected the paper October-November 2023, and it's of 0620, and the variant is 41. The total time for this paper is 1 hour 15 minutes. It's paper 4, which means theory, extended version. You have to answer all the questions. You can use black or dark blue pen. You may use an HB pencil for any diagrams or graphs. So you can use calculator. For the information, the total mark for this paper is 80. The periodic table is printed in the question paper. It's like that. This is periodic table. So let's start the paper. Here's question number 1. A list of gases is shown. This ammonia, carbon dioxide, carbon monoxide, ethene, fluorine, oxygen, sulfur dioxide, xenon. Answer the following questions using only the gases from the list. Each gas may be used once, more than once, or not at all. Give the name of the gas that, part A, causes acid rain. So if you look at the list, you will find acidic oxides in the list. We have 2 acidic oxides, carbon dioxide and sulfur dioxide. Both are acidic oxides, which means both will be responsible for acid rain. But the main culprit for the acid rain is sulfur dioxide. It's not carbon dioxide. So you write sulfur dioxide. B, forms an alkaline solution when dissolved in water. So if you look at the list, in the list, you can see only ammonia is a gas which when dissolved in water produces alkaline solution. This is a reaction between ammonia and water. This is H2O water. It's weakly alkaline solution, so I will show the sign as reversible here. You will get NH4 positive ion in the solution and OH negative ion. Due to the presence of this OH negative ion, the solution is alkaline. So I will write ammonia here. Part C is inert. It's very easy. Xenon is in group 8. You will see group 8 elements. We have group 8 here. Here's xenon. It's one of the inert gases. So definitely you will write xenon here. Part D is a product of photosynthesis. Now, during photosynthesis, the products produced are glucose and oxygen. So we find oxygen here. We don't have glucose, so answer must be oxygen. E, can form a polymer. If you look at the list, in the list you have ethene. Ethene is alkene, which on polymerization forms a polymer. On polymerization gives a polyethene. So definitely the answer must be ethene. Part F is produced in the test for nitrate ions. So for the test of nitrate ions, we usually warm the solution with aluminium powder. and aqueous NaOH. And this produces a gas which pungent smell. It's NH3. It's ammonia gas. So we have this ammonia gas in the list. So definitely the answer must be ammonia for this one. Moving to next question. Number 2, boron and aluminium are group 3 elements. Part A. Boron has only 2 naturally occurring isotopes, B10 and B11. Complete table 2.1 to show the numbers of protons, neutrons, and electrons in an atom of B11. So for proton number, I have to look at the periodic table. Where is boron? Here is boron. The proton number is 5. So I will write the proton number of boron here. Five proton number means it must have 5 protons. And it's a neutral atom, so there must be 5 electrons. What about neutrons? In order to calculate the neutron, you have to subtract 5 from 11. So 11 minus 5, you will get 6. Moving to next part, the relative atomic mass of boron to 1 decimal place is 10.8. Determine the relative abundance of B10 present in boron. Give your answer as a percentage. Now the AR or relative atomic mass of boron is given, which is 10.8. We need to find the relative abundance of B10. They are mentioned in the question. There are 2 isotopes, B10 and B11. So if I will consider X as the percentage abundance of B10, then for B11, it should be 100 minus X. So the equation will be like this. 10x plus 11. That will be the nucleon number of other isotope. And in the bracket, you will write 100 minus X. This whole will be divided by 100 and is equal to AR, which is 10.8. Now, solving this equation, you will get 10x plus 11 multiplied by 100, 1100, 1100 minus 11x divided by 100 is equal to 10.8. Now, 100 will be multiplied on both sides of the equation. It will be cancelled out. And solving the equation further, we will get 10x minus 11x gives minus x. And minus x plus 1100 is equal to 10.8 multiplied by 100. 10.8 multiplied by 100. You will get what? 1080. 1080. Or you can write minus x plus 1100 minus 1100 is equal to, I'm subtracting 1100 on both sides of the equation, minus 1100. These will be cancelled out, so it will become minus x is equal to 1080. Let's solve it. 1080 minus 1100. minus 1100 minus 20 will be cancelled out. So the answer must be 20% for this question. Part 2. Use the relative atomic mass of boron to calculate the number of atoms in 0.50 gram of boron. AR of boron is given. We need to calculate the number of atoms in 0.50 gram of boron. So the best route will be to convert this into moles. You know the moles formula in order to calculate the moles. Number of moles is equal to mass in grams divided by AR or MR. In this case, we have AR. So the mass is given, which is 0.50, and it will be divided by AR, which is given here, 10.8. So 0.50, 540 divided by 10.8. These will be the number of moles, 0.05 moles. Now, in order to calculate the particles, number of atoms, here they mentioned number of atoms, which are actually particles. We have to multiply the number of moles by the Avogadro number. Here's the formula for calculating particles, number of particles. In this case, it is atoms is equal to number of moles multiplied by Avogadro number. The number of moles, that's 0.05, multiplied by Avogadro number is 6.02 into 10 raised to power 23. So if you will multiply 0.05 by 6.02, will become 0.301. 0.301 multiplied by 10 raised to power 23, or shifting the sign from left to right hand side, we will get 3.01. As we have shifted the decimal from left to right hand side, I have to decrease this number and it will become 22. So the answer must be 3.01 into 10 raised to power 22. These are the number of atoms, the mass provided to us. Moving to next question, that's part C. Aluminium is extracted from its purified ore as shown in figure 2.1. So here's a figure. Number 1, name the ore of aluminium. The ore of aluminium is bauxite, so I will write bauxite here. During the extraction, this ore is used. Part 2, the electrolyte contains aluminium oxide and one other substance. Name the other substance and explain why it is used. Now, the melting point of bauxite is very high. First of all, it's purified to get alumina. Alumina again contains very high melting point because aluminum is very strongly bonded to oxygen. Very strongly bonded, strong bonding, strong ionic bonding. So you have to add a compound of aluminium in order to decrease the operating temperature. You can even say that in order to improve the conductivity. So the substance used here, it's cryolite. The name is cryolite. Next explanation, it lowers operating temperature. Explanation will be lowers operating temperature. Or you can even write improves conductivity. Number 3, write the ionic half equation for the reaction at the cathode. At the cathode, there will be gain of electrons. Here we have aluminium 3 plus ion, which will gain 3 electrons to produce molten aluminium. So you write Al plus 3 or 3 plus, both are correct. Plus 3 electrons, 3 moles of electron are needed to form 1 mole of aluminium. Number 4, explain why the anodes need frequent replacement. Now at anode, you look at this anode, these are the anode. They are made up of graphite, carbon graphite. The temperature is very high, made up of graphite. Now temperature is very high. This graphite get oxidized or it react. You can write carbon or graphite react with oxygen to form carbon dioxide. Because oxygen is produced at anode, so it will react with the carbon of graphite. And during this reaction, carbon dioxide is produced. And this results in the reduction of carbon anode. So this needs to be replaced frequently. So you write at anode, carbon reacts with oxygen to produce carbon dioxide. D, state 2 physical properties of aluminium that make it suitable for use in overhead electrical cables. So definitely one of the property of aluminium is that it's a good conductor of electricity and it's light or have low density. So you write good conductor of electricity. Second point, light or low density. Moving to next question. E, explain the apparent unreactivity of aluminium. During reaction, it forms an oxide layer which prevents its further reaction. In other words, it's unreactive or impermeable. So you'll write aluminum oxide layer. The name of the layer is aluminum oxide layer. So aluminum oxide layer. Oxide layer prevents further reaction. We can write is unreactive. Part F, aluminium reacts with fluorine to form aluminium fluoride, AlF3, an ionic compound. 1. Write the symbol equation for this reaction. So symbol for aluminium is Al. Symbol for fluorine. If you look at the periodic table, here is fluorine. But you can't write F for fluorine. Fluorine, they are halogen. It's in the group 7, which is halogen. So halogens, they all exist in the diatomic state. So you will write F2. And the formula of the product, we have already mentioned, which is AlF3. Now let's balance the equation. So in order to balance the fluorine, if I will place 3 before F2, then I need to place 2 before AlF3. This makes 6 atoms of fluorine on both sides. What about aluminum? Aluminum is not balanced. So on the reactant side, you will write 2 before Al. Now it's balanced. Moving to next question. Complete figure 2.2. Show the electronic configuration of one aluminum ion and one fluoride ion. Show the charges on the ions. So where's aluminum? Here's aluminum. It's in group 3. Fluorine is in group 7. Group 3, the valency of group 3 is +3. And group 7, it's -1. And if you work out the formula between these two, it will become like this. AlF. So I'm writing the valency for aluminum, which is +3. For fluorine, it's -1. Ignore the charges. Become 3, 1. Subscript. These subscripts will be exchanged. In the end, you are getting what? AlF3. They have already mentioned AlF3, which means there will be 3 atoms of fluorine for 1 atom of aluminum. The reason is that aluminum is in group 3. As you can see from here, it's in group 3. It will lose 3 electrons. All of this, it's 3 valence electrons. And each fluorine atom will be taking up or gaining these electrons. So for the aluminum, if you look at the proton number of aluminum, it's 13, which means it has 13 electrons. Al, initially 13 electrons. So the configuration must be like this: 2, A, 3. So during the bonding, it will lose all of these 3 electrons, each fluorine atom. So fluorine atom, we have 3 fluorine atoms. So I'm writing 3 before F, which means you have to remember that there will be 3 fluorine atoms. The electronic configuration of fluorine. The proton number of fluorine is 9, which means the configuration must be 2, 7, which means it's accepting 1 electrons, which is coming from aluminum, plus 1. For each fluorine, they are gaining 1 electrons, which is coming from aluminum. So let's draw the electrons left for aluminum in this. These electrons will be left. They have already shown 2 electrons. Now we need to show 8 electrons. So I will draw one circle here. So I need to show 8 electrons. We will use cross for the electrons of aluminum. 1, 2, 3, 4, 5, 6, 7, 8. And it has lost 3 electrons. So you write +3 or 3 plus. +3 or 3 plus. Both are correct. What about fluorine? Fluorine will gain 1 electron. So one of the electron must be of cross. The electrons, I will use dot. So it's the circle. First, I'm going to show the 7 valence electrons of fluorine. 1, 2, 3, 4, 5, 6, 7. Now 1 electron coming from aluminum, so I will show cross here. And it has gained 1 electron, so I will write minus sign outside the bracket. Question number 3. Our order of reactivity can be determined by displacement reactions. Part A, a student investigates the reactivities of 4 metals by carrying out a series of experiments. Each of the metals, lead, manganese, silver, and zinc, are added separately to aqueous metal nitrates of the other metals. Number one, table 3.1 shows some of the results. So here's table 3.1. If you look at the results, lead to nitrates, it's displaced by aluminium. It's displaced by manganese only. Manganese nitrate is not displaced by any of these metals. Silver nitrate is displaced by lead, manganese, and zinc. And zinc nitrate, it's not displaced by lead as well as manganese. The cross shows that displacement reaction does not take place. Tick shows that displacement reaction occurs. So this is the information we are having. Complete table 3.1 and place the four metals in their order of reactivity with the most reactive first. So looking at this position, AG won't be able to displace. AG won't be able to displace any of these. Because if you look at the reaction of silver nitrate with the lead, manganese, and zinc, we can see the tick sign, which indicates these all are displacing zinc. So I will write cross for silver straight away. What about PB, lead? Will manganese displace lead? Yes, manganese is displacing lead. So for PB, you will write cross here for manganese to nitrate. And zinc, it will definitely displace all of these. So it will displace lead to nitrate, yes. It will displace manganese to nitrate, yes. This one is also cross. Now we have the situation here. Zinc being the most reactive one will come first. So I will write the Zn first. And Ag must be the least reactive. So I will write on fourth Ag. Now we are left with lead and manganese. Look at lead and manganese. Manganese is displacing lead to nitrate, so manganese must be more reactive than lead. So I will write Mn. Then after Mn we have Pb. This will be the final series according to this table. Suggest why the metal nitrates and not the metal sulfates of these four metals are used as the aqueous solutions. Definitely all nitrates are soluble, but sulfate is insoluble. We'll write all nitrates are soluble. We have one of the sulfate. If you look at this series, one of the sulfate of these is lead. So besan ke laddu, all sulfates are soluble except besan ke laddu. All sulfates are soluble except besan, barium, K, Ca, calcium, laddu, Pb, laddu, Pb. Besan ke laddu, lead sulfate is insoluble. So you can even write lead sulfate insoluble. Write the symbol equation for the reaction between zinc and silver nitrate. Here's a symbol for zinc, Zn, and for silver nitrate, it is AgNO3. It's a single displacement reaction. Zinc being more reactive than silver will displace silver from its nitrate. So you will get zinc nitrate, Zn. What will be the formula of zinc nitrate? Zn, it carries +2 charge. Nitrate NO3, it carries -1 charge. Ignore the charges. These subscripts will be exchanged and you will get ZnNO3 whole twice. So I will write ZnNO3 whole twice plus Ag. Now we balance the equation. We need to put 2 before AgNO3, and on the product side we have 2Ag. So this will be the final balance equation. B, the reactivity of group 7 elements can be investigated experimentally. A student bubbles chlorine gas into a test tube containing aqueous potassium bromide. Number 1, describe the color change seen in the test tube. So if you look at the position of bromine, it's bromine. Bromine is below chlorine. So the reactivity trend in group 7, it's that decreases down the group. Reactivity in group 7 decreases down the group. The reason is that they all are non-metals. They need to gain 1 electrons as they are in group 7 to complete the valence shell. And as you go down the group, what's happening? There's addition of a shell and the valence shell. It's moving further away from the nucleus. So the incoming electron experiences less force of attraction by the nucleus. So the top one will displace the non-metals or halogen below it from their compound. So if you will bubble chlorine gas into a test tube containing aqueous potassium bromide, definitely the reaction will take place. So the color will change from, initially the color will be colorless. So it will change and it indicates the formation of bromine. So bromine in the aqueous solution, bromine is orange. So you write orange here. Number 2, complete the ionic equation for this reaction. Include state symbols. So I need to write the ionic equation for this reaction. So we are bubbling chlorine. So all the halogens, they exist in the diatomic state. So I will write chlorine Cl2. State symbol for chlorine will be gas. And on the product side, you will get bromine liquid. So you write Br2. The state symbol will be L. And for the chloride ion, you will get chloride ion as a result. So we have aqueous chloride ion. So let's balance the equation. Need to put 2 before Br minus and 2 before Cl minus. Now in the marking scheme, they are saying Br2 aqueous, which is also acceptable. Bromine water, you heard about it. It's bromine water. So it's also acceptable. Otherwise, bromine exists in the liquid state. The reactivity trend seen in chlorine, bromine, and iodine applies to all the elements in group 7. Use the periodic table to identify the group 7 element which cannot displace any other group 7 elements. So if you look at the group 7, we have chlorine, bromine, iodine, astatine, and tennessine. So it must be tennessine that cannot displace any other element in this group. So you write the symbol of tennessine, that is TS, or even you can write the name of tennessine, TENESSINE, tennessine. So here's question number 4. aqueous hydrogen peroxide H2O2 slowly forms water and oxygen at room temperature and pressure RTP. This reaction is catalyzed by manganese 4 oxide. The equation is shown. 2H2O2 aqueous gives 2H2O plus O2. A. State the test for oxygen gas. Now the test for the oxygen gas is glowing splint and it relights. So you write glowing splint. Glowing splint. You'll write relights or even rekindle. Part B. A student investigates the rate of formation of oxygen gas when manganese 4 oxide is added to aqueous hydrogen peroxide. The volume of oxygen gas formed is measured at regular time intervals at RTP. The results are plotted onto the graph in figure 4.1. So here's a graph. Number 1, state how the graph in figure 4.1 shows the rate of reaction at time T2 is lower than at time T1. Now, if you will compare it, the gradient, it's decreasing. Here it's decreasing. So you write lower gradient at T2. Lower gradient at T2. Number 2, explain using collision theory why the rate of reaction at time T2 is lower than at time T1. So it's definitely as the reaction progresses, the concentration of H2O2 particles, they are decreasing. So there will be less frequency of collision between particles. Or you can write lower frequency of collision. So you can write concentration of H2O2 particles decreases. Concentration of H2O2 particles decreases, which means there will be low frequency of collision. Lower frequency of collisions between the particles. Number 3, on figure 4.1, sketch the graph obtained when the experiment is repeated using aqueous hydrogen peroxide at a higher temperature. All other conditions remain the same. Now, if you increase the temperature, the graph will be more steeper. So you'll have steeper graph than this. So it will be like this. Remember, it should levels off before the original line. So this will be the curve obtained in this case. Part C, manganese 4 oxide is added to 20 centimeter cube of aqueous hydrogen peroxide. The total volume of oxygen gas produced is 72 centimeter cube at RTP. The reaction is given. Calculate the concentration of the aqueous hydrogen peroxide in gram per decimeter cube using the following steps. Step number 1, calculate the number of moles of oxygen gas produced. Total volume of oxygen gas produced is given, which is 72 centimeter cube at RTP. And you know that at RTP, the volume is 24,000 centimeter cube. So we'll write for 1 mole, volume is 24,000 centimeter cube. Therefore, there will be X mole for 72 centimeter cube. Do the cross and the equation becomes like this. X is equal to 72 divided by 24,000. 72 divided by 24,000 gives 0.003. 0.003. These are the moles of oxygen. Next one, determine the number of moles of hydrogen peroxide which reacts. Now, if you look at the relation between H2O2 and O2, it will be like this. H2O2. So you have 2 moles of H2O2 giving 1 mole of O2. Therefore, X moles for 0.003 moles of O2. Do the cross, it will be 0.003 multiplied by 2. 0.003 multiplied by 2, which becomes 0.006. So these are the moles of H2O2, 0.006 moles. Now calculate the concentration of aqueous hydrogen peroxide in mole per dm cube. So these moles are in 20 centimeter cube. So you write 20 centimeter cube contains 0.006 moles. Therefore, 1000 centimeter cube contains X moles. Do the cross, you will get X is equal to 0.006 multiplied by 1000 and divide the answer obtained by 20. 0.006 multiplied by 1000 divided by 20, and the answer is 0.3 moles. 0.3 moles per dm cube of H2O2. Now we need to calculate the concentration of aqueous hydrogen peroxide in gram per decimeter cube. For this, you need the MR of H2O2. MR of H2O2. We have 2 atoms of hydrogen, so 2 multiplied by, here is hydrogen. Here is hydrogen, it's having 1 as its nucleon number. What about oxygen? Here is oxygen, 16 as its nucleon number. So 2 multiplied by 1 plus 2 multiplied by 16. So this becomes 2 plus 32. 2 multiplied by 16, 32. 32 plus 2 is 34. Now we need to convert this moles into grams. Recall the formula. The formula is number of moles is equal to mass divided by MR. So we are calculating mass. So you can write or mass is equal to number of moles multiplied by MR, which means 0.3 will be multiplied by 34. 0.3 multiplied by 34, and you'll get 10.2. So the answer must be 10.2. This will be the final answer, 10.2 grams per decimeter cube. D. Suggest the identity of one other metal oxide which also catalyzes this reaction. You can take any transition metal oxide. Transition metal oxide, they act as a catalyst. Any transition metal oxide. For convenience, I am giving some example like iron oxide, copper 2 oxide, or MnO2, etc. Number 5. Methane reacts with steam to produce hydrogen gas. CH4 plus H2O gives CO plus 3H2. These all are in the gas state. That's why I'm not stating the state symbol. Say delta H is plus, which means the forward reaction is endothermic. I'm writing it here, endothermic. The reaction takes place at 1000 degrees centigrade and 100 kilopascal pressure. A. The reaction is reversible and reaches an equilibrium in a closed system. State 2 features of an equilibrium. One of the features is the rate of forward reaction is equal to the rate of the reverse of backward reaction. Rate of forward reaction is equal to the rate of reverse reaction. The other feature is that the concentration of reactants products are no longer changing. The concentrations of reactants and products are no longer changing. Be careful with the line. You must have your answer in the line provided to you. Part B, state and explain in terms of equilibrium what happens to the concentration of hydrogen when. Now they are asking about what happens to the concentration of hydrogen when the pressure is increased. So if you increase the pressure, what will happen? The equilibrium will shift to the side where there will be less moles of gas. So let's write the number of moles or volume of gases on both sides. On the reactant side, it's 1 plus 1, and the product side 1 plus 3. So on the reactant side, it's 2. 2 moles gives 3 plus 1, 4 moles. So which means the concentration of H2O must decrease. So you write concentration decreases. Concentration decreases. Now you have to explain. In explanation, you have to explain in which direction the position of equilibrium will shift. The equilibrium will shift to the left-hand side. Position of equilibrium shifts to left side. And you can see there will be less or fewer moles of gas on left hand side. As we have already mentioned, there are 2 moles of gases on the left hand side and few moles of gas on left hand side. Now, what will happen if you increase the temperature? Temperature is increased. Temperature increase will shift the equilibrium to the side which is endothermic. So forward is endothermic. So definitely it will move to the right hand side. So your light concentration increases. They're asking now what happened to the concentration of hydrogen. So your light concentration increases. So next you light position of equilibrium. Shifts to right side, and forward action is endothermic. Number 3, a catalyst is used. Now there will be no effect. Remember, there will be no effect. The reason is that catalyst increases the rate of reaction both the directions. So overall, the catalyst has no effect on the position of equilibrium. So you'll write no change. Then on explanation, you write catalysts do not affect position of equilibrium. Part C, methane is a greenhouse gas which contributes to global warming. 1. Name a greenhouse gas found in clean, dry air. So other greenhouse gas which is found in clean and dry air is carbon dioxide. So you write carbon dioxide. Part 2, explain in terms of thermal energy how greenhouse gases cause global warming. So first of all, you have to mention that these greenhouse gases, they absorb thermal energy from the earth. So we'll start writing greenhouse gases absorbs thermal energy from the earth. Now it's of 3 marks, so you have to give 2 reasons. I mean 2 explanations. You have to give 2 explanations for this. So you can write any 2 from these. So now what they are doing, they are absorbing the earth's surface, it's absorbing energy from the sun. So we'll write energy from the sun absorbed by the earth's surface. And then this earth, it's reflecting energy. Earth reflects thermal energy. Next point, these greenhouse gases, they are reducing the loss of this thermal energy into space. Greenhouse gases stops thermal energy loss into the space. Then what's happening? Due to the increasing amount of greenhouse gases, it results in a increase in temperature. of the earth. Increasing amount of greenhouse gases higher atmospheric temperature. Moving to next question, which is about ethanol. Ethanol is manufactured by two methods. Method 1, fermentation of aqueous glucose. Method 2, catalytic addition of steam to an alkene. A. Method 1 takes place at room temperature and pressure. State two other conditions needed in method 1. So it takes place in the absence of air. So you can write absence of air or anaerobic condition. Absence or of air or anaerobic condition, and it takes place in the presence of yeast. Yeast produces an enzyme, zymase, which catalyzes this reaction. Part B. State the typical temperature and pressure used in method 2. Method 2 is industrial. The temperature is 300 degrees centigrade and pressure is 6000 kilopascal. Something which you have to learn. Part 2, name the alkene used in method 2. What you are making? You are making ethanol. So ethanol, for ethanol, the alkene uses must be ethene. So I will write ethene here. Part 3, state why the reaction in method 2 is referred to as an addition reaction. The reason is that there will be only one product is produced. So you write only one product produced is produced. There aren't any other product. That's why it's referred to as addition reaction. Part 3, the catalyst in method 2 is phosphoric acid, H3PO4. Dilute phosphoric acid is a weak acid which contains phosphate ions, PO4 3-. Number 1, state what is meant by the term acid. Acid, it's a proton donor. This is the definition of acid. They are proton donor. So you write proton donor. Number 2, state the meaning of weak in the term weak acid. Partial dissociation or incomplete dissociation. Partial or incomplete dissociation. Number 3, determine the oxidation number of phosphorus in PO4 3- ion. Show your working. So PO4 3-, we need to find the oxidation number of phosphorus. Let's consider phosphorus as X in this. X plus, there are 4 atoms of oxygen. What will be the oxidation number of oxygen in this? Where is oxygen? Here is oxygen. Oxygen is in group 6. It's on top of this group. So it must be having -2. The oxidation number for this group is -2. In this case, it's above phosphorus. It's highly electronegative, so it must be carrying -2 charge. And the overall charge on phosphate ion is given, which is 3-. So you write -3 here. Moving to next step, X. 4 multiplied by -2, you will get -8 is equal to -3, or X -8 plus 8 is equal to -3 plus 8. 8 will be cancelled on this side. The final answer must be +5. Part D. Give one advantage of each method of production of ethanol. So method 1. In method 1, where is method 1? So method means fermentation of aqueous glucose. So we are fermenting this glucose. It's obtained from renewable resources, from sugar cane. Glucose is obtained from sugar cane, which is renewable resource. What about method number 2? We are getting only one product. That's a pure product. You can even say the rate of reaction will be high because of the temperature. If you look at the temperature is 300 degrees centigrade. So method 2, you can write with high rate of temperature or only one product obtained. So method 1, you will write renewable, uses renewable resources, uses renewable resources. For method 2, you will write high rate of reaction, or product obtained is pure. Product obtained is pure. You are getting only one product. Part E. Ethanol can be converted to ethanoic acid by reacting it with an acidified oxidizing agent. Name the acidified oxidizing agent. It's potassium magnate 7. So we'll write potassium manganate 7. Number 2, state in terms of redox what type of reagent ethanol is in this reaction. Definitely, if potassium magnate is the oxidizing agent, so ethanol must be the reductant or reducing agent in this reaction. So we will write reducing agent. Part F, ethanoic acid reacts with calcium to form a salt and one other product. Name the salt. So whenever acid reacts with the metal, they will produce alkanoate, metal alkanoate. So in this case, we'll be getting ethanoate. So you'll write calcium ethanoate. Name the salt calcium ethanoate. Write the formula of the salt. Now for the formula of the salt, it's between calcium and ethanoate ion. Ethanoate ion is CH3COO. It's carrying -1 charge. And calcium. Calcium, where is calcium? Here is calcium. It's in group 2. Group 2 carries +2 charge. +2 is its valency. Ignore the charges. 1, 2. Here we have 1. We are having 2. These subscripts will be exchanged. So we get 2, 1, which means CH3, COO whole twice Ca. This will be the final formula. CH3, COO whole twice Ca. Identify the other product in this reaction. The reaction between acid and metal, and you will always get hydrogen gas in this reaction. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.